When the Germans first saw America's wooden planes, they laughed, but their laughter stopped cold when they met the wooden wonder. And the story of why is one you were never told. You might remember the Havilland Mosquito, the British marvel made of wood. But do you know why German pilots ridiculed the American wooden planes that came just before it? Wood was a terrible material for warplanes. Or was it? The Germans thought they knew the answer, until a wooden plane they couldn't catch started tearing their war effort apart. When the leadership of the Luftwaffe first received intelligence reports about America's new pilot training aircraft, the mood in Berlin was not one of concern. It was one of ridicule. German engineers, men who had built the world's first jet fighters and rocket planes, looked at the specifications for these new American planes, and they scoffed. They called them Spur-Holzsarge, plywood coffins. They dismissed them as matchstick curiosities, the desperate work of a nation that, for all its industrial might, was clearly scrambling to save metal. The laughter in the Reich Air Ministry was loud and confident, a reassuring sound for a leadership already convinced of its own technological superiority. But just a few months later, that laughter would die in their throats. It would be replaced by stunned silence, then by frustration, and finally, by outright fear. Their frontline pilots over France and Germany began reporting encounters with a new Allied aircraft. It was a phantom, a ghost in the sky that appeared out of nowhere, flew faster than their best fighters, and disappeared before they could even get a firing solution. They called it the Mosquito. This Mosquito, this British-built wooden wonder, was a plane they couldn't catch, couldn't shoot down, and simply could not believe was made of the very same material they so openly mocked. The story of why the Germans ridiculed one set of wooden planes and were completely terrorized by another is the story we are going to tell today. It's a fascinating, often overlooked chapter of the Second World War. It reveals a critical truth about wartime innovation, a truth that goes far beyond just airplanes. It's a story about the deadly, deadly difference between a good idea and good execution. It's a tale of American industrial might, the greatest the world had ever seen, stumbling badly over its own feet. And it's the story of how the very thing that Germans laughed at would eventually be adopted by the Americans themselves, flown by U.S. pilots, and used to help tear the Third Reich apart. So what was the disconnect? Why were the American-made wooden aircraft seen as such a dangerous, amateurish joke, while the British Havilland Mosquito became one of the most effective and feared weapons of the entire war? The answer is complex. It begins not in the sky, but on the factory floor. It begins with a desperate search for materials, a forgotten art, and a race against time that America, in the beginning, was badly losing. To truly understand the German ridicule, we have to transport ourselves back to the darkest days of the war. It's 1940 and 1941. Europe is ablaze. The German war machine has crushed Poland, France, Belgium, and the Netherlands. Britain is fighting for its very life, alone, in the skies over London. America, while still officially neutral, is watching with growing alarm. President Franklin D. Roosevelt, in one of his famous fireside chats, makes a promise. America will become the arsenal of democracy. This was not just a political slogan. It was a promise to retool the entire massive United States economy for war. In May of 1940, Roosevelt stunned Congress and the world by calling for the production of 50,000 airplanes per year. At the time, the U.S. military had fewer than 3,000 planes in its entire inventory, many of them obsolete. 50,000 seemed like a fantasy.
But as American industry, with its characteristic can-do spirit, began to ramp up, the men in charge of planning, men like William Knudsen at the new Office of Production Management, ran into a terrifying bottleneck. It wasn't manpower. It wasn't factory space. It was materials. A modern, all-metal airplane of that era was a hungry beast. A single B-17 Flying Fortress bomber required over 50,000 pounds of aluminum. A P-40 Warhawk fighter needed over 6,000 pounds. And it wasn't just aluminum. It was high-grade magnesium for engine components, specialized steel alloys for landing gear, copper for the thousands of feet of wiring. The demand for these strategic materials was simply skyrocketing, Every tank rolling out of the Detroit arsenal, every destroyer sliding into the water at the Kearney shipyards, every single machine gun bullet was competing for the same limited resources. The United States was a continent rich in resources, but it couldn't just magically create more bauxite ore, the raw material for aluminum, overnight. The smelting capacity, which required colossal amounts of electricity, was already being pushed to its limit. The planners at the War Production Board, the government body that succeeded the OPM and was given vast power to orchestrate this industrial miracle, ran the numbers. They saw a future, perhaps only a year or two away, where the production lines for the B-17s, the B-24s, and the P-51s, the truly critical frontline machines, might be forced to slow down or even stop, not for lack of engines or workers or factories, but for lack of simple aluminum sheet. This singular crisis, this looming aluminum famine, forced a radical and, to many, a backward-looking solution: wood. It wasn't just a nostalgic whim. The idea, championed by men within the WPB and the aviation industry, was to use wood, a plentiful, non-strategic, and domestically available resource, to build the secondary aircraft. This meant the thousands upon thousands of planes needed for the pilot training pipeline: primary trainers, basic trainers, and advanced trainers. It also meant transport aircraft, utility gliders for the new airborne divisions, and perhaps even coastal patrol bombers. The logic was powerful and easy to understand. Every single trainer built from plywood and fabric would free up enough aluminum to build a frontline fighter. It was a seemingly brilliant, common-sense trade-off. It looked like the perfect American solution: ingenuity, resourcefulness, and mass production. But this plan, so logical on paper, had a fatal flaw. A flaw that stemmed from a complete and total loss of institutional memory. You see, America had built thousands of wooden planes in the First World War. The famous Curtiss JN-4, Jenny, the plane that taught a generation of barnstormers to fly, was a creature of wood, fabric, and wire. But the military had learned a bitter lesson from those aircraft. Those planes, built with simple animal-based glues and early casing adhesives, were fragile. They didn't hold up. In the rain and mud of the fields in France, their wooden frames rotted. The fabric coverings mildewed. In the tropical humidity of the Philippines or the Panama Canal Zone, the wings would literally delaminate, the glue joints failing as the wood warped and swelled. They were a maintenance nightmare. Because of this experience, the 1920s and 30s saw American aviation pioneers turn their backs on wood completely. They embraced the all-metal revolution. Visionaries like Jack Northrop, Donald Douglas, and the engineers at Boeing championed the stressed-skin, all-metal monocoque design. The Douglas DC-3, the Boeing 247, and the B-17 Flying Fortress proved to the world that metal was the future. It was durable. It was strong. It could withstand the elements. And once you built the massive, expensive tools, the hydraulic presses, the jigs, the stretch formers, it was actually easier to mass produce with consistent quality. An aluminum sheet is the same every time. A rivet is a standard, predictable fastener. Wood, on the other hand, was a natural material. Every piece was different. It required a craftsman's touch, a feel for the material that you couldn't easily teach to a new worker on an assembly line. As a result, by 1940, the art of building high-performance wooden aircraft in America had simply died. It was gone. The master craftsmen who knew how to laminate spars, how to steam bend a complex curve, how to mix and apply glues for maximum strength, they had all retired or retrained as metalworkers. The specialized knowledge of wood stresses, of resin chemistry, of load-bearing laminates, it was lost, replaced by rivet guns and hydraulic presses. So when the call came in 1941 from the War Production Board to build wooden planes again, American industry was starting from almost zero. It was this inexperienced, rushed, and desperate scramble that produced the very aircraft the Germans would soon come to ridicule. The most glaring examples, the ones that German intelligence picked up on first, came from that massive pilot training program. The need was staggering. The Army Air Forces needed to create the largest air force in the world, and they needed to do it immediately. This meant training hundreds of thousands of young men. They needed planes, and they needed them by the thousands. Companies like Fairchild, Ryan, and Stinson stepped up with designs. The most numerous, and later the most infamous of these, was the Fairchild PT-19 Cornell. It was, on paper, a beautiful aircraft. It was a sleek, low-wing monoplane. It looked far more modern than the old fabric biplanes, and it was meant to give cadets a feel for a more modern hot ship, something closer to the Spitfire or the P-40 they would soon be flying. And its fuselage and wings were built almost entirely of plywood, molded and shaped to be aerodynamic and light. It was the perfect solution to the aluminum shortage. But here is where the problem began. Fairchild's own factory in Hagerstown, Maryland, couldn't possibly build them fast enough. The Army needed thousands now. So the government did what it had to do in wartime. It spread the contracts out. But who do you get to build a complex wooden aircraft in a country that has forgotten how? You get furniture companies. Contracts for the PT-19 and its variants were given to companies like the Howard Aircraft Corporation, to Aeronca, and, most notably, to furniture and cabinet makers. These were companies that knew wood. Yes, they knew how to build a chair, a table, or a high-quality piano, but they had absolutely no idea how to build a machine that had to withstand the incredible stresses of flight, the vibration of a powerful engine, and the bone-jarring abuse of a student pilot practicing landings over and over. The learning curve wasn't just steep, it was a sheer cliff. And the critical point of failure, the single element that would earn these planes their deadly reputation, was the glue.
Now, this wasn't the old-fashioned animal hide glue from World War I. This was new, miracle plastic resin glue. The most common was urea formaldehyde, a synthetic resin that in a controlled laboratory was fantastic. It was waterproof, it was fungus-resistant, and when cured, it created a bond that was in theory stronger than the wood itself. But, and this is the but that cost lives, it was incredibly, disastrously finicky. To cure properly, these synthetic glues required conditions that were almost impossible to maintain on a wartime factory floor. They needed exact temperature, they needed precise low humidity, they needed to be mixed in exact ratios with no deviation, and they required specific, maintained clamping pressure for an exact number of hours to set. Now picture a factory in North Carolina in the summer, or Michigan in the winter. It's 1942. The factory is staffed by newly trained workers, many of whom were building sofas or dining tables 6 months earlier. The pressure from the Army to meet quotas is immense. A batch of glue might be mixed with slightly the wrong ratio of catalyst. A supervisor, trying to speed up the line, might tell the workers to unclamp a wing spar an hour early. A sheet of plywood, sitting on the factory floor over a humid weekend, might absorb invisible moisture from the air before it was sealed into the wing. On the assembly line, the wing looked perfect. The paint was shiny, it passed a simple inspection, was bolted to a fuselage, and was rolled out the door to a nearby training base in Texas or Florida or Georgia. Then, the student pilots, young men barely 18 or 19 years old, took them up, and the planes sat outside. They were staked down on hot, humid, or rain-soaked airfields. The brutal Texas sun baked the wings. The Florida humidity seeped into every microscopic crack, and the improperly cured or improperly applied urea formaldehyde glue began to fail. The official term they used was glue failure. A more terrifying and viscerally accurate term was structural delamination. We've read the reports from mechanics at these bases. They are chilling. They would walk down the flight line, tapping on the wings of the PT-19s. Instead of the solid, resonant thunk of a healthy wooden wing, they'd hear a sick, hollow, dead sound. They knew in that instant that the plywood skin had peeled away from the main spar inside. The PT-19 in particular developed a grim reputation for its main wing spars, the structural backbone of the wing, simply rotting from the inside out. Moisture would get trapped, and the wood, not properly sealed, would just decay. Cadets started hearing creaks and groans in flight that a new airplane should never make. They would practice their spins and dive recoveries, maneuvers designed to test their skill and the plane's limits, and then the wing would simply fold up. In a hard pullout from a dive, a maneuver every single student pilot had to master, the wing would fail. The plywood skin, no longer bonded to the spar, would rip away, the wing would collapse, the plane and the student would be lost. This wasn't a secret. The Army Air Forces tried to keep it quiet, but pilots, with their dark gallows humor, talked. Mechanics cursed the manufacturers and the inspectors. The nickname flying coffin wasn't invented by the Germans, it was invented by the American pilots who had to fly them. And of course, German intelligence, with its network of attachés in neutral countries, its listening posts, and its analysis of American newspapers, picked up on this chatter. These reports flowed back to Berlin. They were a propaganda gift. They confirmed exactly what the German High Command already believed: wood was an inferior, obsolete material. The Americans, for all their talk, were amateurs. They were so desperate for aluminum that they were killing their own pilots with shoddy, rotting airplanes. It was, to the German mind, a joke, a sign of a fundamentally weak and desperate enemy. And this was just the trainer problem, an internal issue that was costing lives, but wasn't yet visible to the whole world. The public face of America's wooden plane folly was something much, much bigger, much more ambitious, and in the end, infinitely embarrassing.
We are talking, of course, about the Hughes H-4 Hercules. The world would come to know it, to its creator's eternal frustration, as the Spruce Goose. The story of this aircraft is a perfect, almost tragic example of American ambition, genius, and obsession colliding at the worst possible time. The idea was born in the darkest days of 1942. The Battle of the Atlantic was at its height, and the Allies were losing. German U-boat wolf packs, operating with terrifying efficiency, were sinking Allied cargo ships in the Atlantic faster than America and Britain could possibly build them. Hundreds of ships, carrying millions of tons of precious food, tanks, ammunition, and fuel, were at the bottom of the ocean. Britain was being strangled. If the U-boats couldn't be stopped, the war would be lost. Into this crisis stepped Henry J. Kaiser. Kaiser was not an aviator. He was a shipbuilder, an industrialist, a genuine miracle worker. He was the man who had perfected mass production of Liberty ships, building them from keel to launch in a matter of days, not months. He was a man who thought on a truly massive scale. Kaiser proposed a truly radical idea. He went straight to the government and said, if we can't beat the U-boats under the water, let's fly over them. He proposed building a fleet of enormous flying boats, cargo planes so large they could carry an entire M4 Sherman tank or hundreds of troops. And to get around the aluminum shortage, he would build them entirely of wood. It was a grand, breathtaking vision. So, the government, desperate for any solution, no matter how outlandish, approved a contract for 3 prototypes. The project was given the highest national priority. But Hughes knew his company knew nothing about aircraft. He needed a partner, and he chose the most famous and most controversial aviator in the world, Howard Hughes. Hughes was a brilliant engineer, a record-setting pilot, and a man who had built successful aircraft before. He was also a notorious, crippling perfectionist. This, it turned out, was a monumental mistake. Hughes, whose own company was soon given control of the project, threw out Kaiser's initial, more practical designs. He declared that he would not just build a large wooden plane, he would build the largest, most advanced, most perfect aircraft in human history, and he would build it almost entirely from wood. But not just any wood. Hughes, a man obsessed with being on the cutting edge, insisted on using a complex and proprietary process his engineers had developed called Duramold. This was not simple plywood construction. Duramold involved laminating dozens of paper-thin veneers of birchwood, not spruce, as the popular name suggests. Hughes hated that name, with a special plastic resin. This giant molded shell would then be baked under heat and pressure in a giant oven called an autoclave, curing into one giant, immensely strong, and perfectly smooth piece. He was in effect inventing composite construction on a scale that had never been attempted. The plane's wingspan was to be 320 feet, longer than a football field. The tail was as tall as a 5-story building. The project became a colossal, headline-grabbing sinkhole for money, resources, and most critically, time. While the factories at Willow Run, Inglewood, and Seattle were churning out thousands of B-24s, P-51s, and B-17s, the specialized Hughes facility in Culver City, California, was painstakingly, slowly crafting one single gigantic wooden airframe. The war moved on.
By 1944, the Allies had landed at Normandy. The tide in the Atlantic had turned. Thanks to long-range patrol bombers like the metal B-24 Liberator, advanced radar, and better convoy tactics. The U-boat menace, while not gone, was largely defeated. The B-29 Superfortress, an all-metal marvel, was firebombing Japan from the Marianas. The original, desperate need for the giant wooden flying boat was gone. And the Spruce Goose? It was still sitting in its specially built, climate-controlled hangar in California. It had cost the government over $23 million, a staggering sum at the time, and it had never even touched the water, let alone flown. It became a national scandal. Senators, led by Owen Brewster, launched an investigation. Hughes was dragged before Congress to testify, defending his honor and his project in a series of dramatic, headline-grabbing hearings. For the German propaganda ministry, led by Joseph Goebbels, this was a gift from heaven. This was the American miracle of production, a giant wooden boondoggle, a flying lumber yard that couldn't even fly. They broadcast it across the world as the ultimate proof that America was a nation of amateurs, all bluster and no follow-through. It perfectly confirmed their deepest-held bias. Wood was an obsolete material for amateurs and fools. The Germans felt smug. They felt secure in their engineering, their steel, their advanced jets. They had no idea what was happening just across the English Channel in a series of small, dispersed, and highly secretive factories run by the de Havilland Aircraft Company. This is where the story shifts dramatically. This is where the German ridicule turned to sheer panic. The de Havilland Company was different. They were unique among the major aircraft manufacturers of the era. Unlike the American companies like North American or Lockheed, who had completely abandoned wood in the 1930s, de Havilland had never stopped building wooden aircraft. Their entire company culture, their entire engineering philosophy, was built around wood. They had built the stunningly beautiful DH-88 Comet Racer, a wooden twin-engine plane that had dominated the 1934 Mack Robertson Air Race from England to Australia. They had built the Albatross airliner, a sleek, 4-engined wooden passenger plane that was a marvel of 1930s aerodynamics. They didn't just know wood, they were the undisputed world's masters of it. So, when the war began in 1939 and aluminum became critically scarce in Britain, far more scarce than it ever would be in America, Geoffrey de Havilland himself went to the Air Ministry with a proposal. But his proposal was not for a simple trainer or utility transport. He proposed something so radical, so audacious, that the Air Ministry officials thought he was insane. He wanted to build a primary, front-line, high-performance bomber. A wooden bomber in 1940 to fly against the cannons of the Messerschmitt 109? It sounded like a suicide mission. The officials politely and then firmly rejected the idea. They wanted fighters. They wanted heavy bombers with multiple gun turrets. But de Havilland, in a classic case of brilliant, stubborn engineering, persisted. He argued that his bomber wouldn't need heavy armor. It wouldn't need defensive gun turrets. Why? Because it would be so fast, nothing in the sky could catch it. He proposed a wooden wonder powered by two of the new magnificent Rolls-Royce Merlin engines. By stripping away the weight of the guns, the gunners, the armor plate, and the heavy metal structure, his plane would be all engines and airframe. Reluctantly, skeptically, the Air Ministry gave him a small contract for a single prototype. Mostly, it said, to keep him quiet. This was the birth of the DH-98 Mosquito. But how exactly could a wooden plane be that fast and that strong? The answer, the one the Americans had missed and the Germans had ignored, lies in the type of wood construction. This is the crucial difference. The American planes, like the PT-19, were built using a traditional, simple design. They had a framework of solid wood spars and ribs, and then a thin plywood skin was nailed or glued on top. It was, essentially, a 1920s design philosophy that was just updated with new glues. It was not a stressed skin design. The skin added little to the strength. The Spruce Goose, on the other hand, was a highly advanced technical marvel, but it was a one-off, custom-built object. It was art, not mass production.
The Mosquito was something else entirely. It was a true monocoque design, which means its skin was its structure. The fuselage, in one of the greatest strokes of production genius in history, was built in two perfect mirrored halves, a left side and a right side, like a giant model airplane. The construction itself was a sandwich. This was the secret. The outer skin was plywood, made from high-quality birch veneers. The inner core of this sandwich was lightweight, plentiful balsa wood, and the inner skin was another layer of plywood. These layers were laid over a giant concrete mold shaped like the side of the fuselage. They were glued together with casein glue, a milk protein-based glue that de Havilland had perfected, finding it more reliable and easier to work with than the new, finicky resins. Later, they would adopt synthetic glues as they improved. The layers were clamped down, and when the two halves were cured, all the internal equipment, the wiring, the controls, the oxygen tanks, was installed on the open floor. Then the two halves were brought together and glued, screwed, and strapped, creating a fuselage that was incredibly strong, perfectly aerodynamic with no rivets or seams, and astonishingly, impossibly light. There were no internal ribs, no stringers, just a smooth, hollow, perfect shape. The wings were built with similar genius. They were a single, massive piece built around two huge laminated wooden box spars. The skin was stressed plywood, meaning it carried a major part of the flight loads. The entire airframe was a masterpiece of advanced, lightweight engineering, but it was built using carpentry. And here is the second, equally important difference. The workforce. De Havilland didn't just go to any furniture maker. They went to the best. They brought in high-end cabinet makers, artisans from bespoke furniture shops, the builders of luxury yachts, and yes, piano makers. These were people who had spent their entire lives working with wood and glue to the highest possible standard. They understood the material. They knew how to read the grain of a piece of birch. They knew how to apply the glue in a perfect, even coat. They could feel when a joint was perfect. This was not the rushed, quota-driven, inexperienced assembly line production of the American trainers. This was high-speed, mass production, but based on a foundation of true craftsmanship.
The result was an aircraft that, when fitted with two of those magnificent Rolls-Royce Merlin engines, was a world beater. The prototype Mosquito first flew in November of 1940. Its performance stunned everyone, including the British Air Ministry. The bomber prototype, with no guns, no armor, and a dummy bomb load, was clocked at just under 400 miles per hour. This was staggering. It was faster than the brand-new Spitfire Mark II, the premier fighter plane the Royal Air Force had. Let me repeat that because it's the key to the entire story. A bomber, made of wood, was faster than the best frontline fighter in the world. The Germans, when their intelligence services first got wind of it, simply didn't believe the reports. They assumed it was exaggerated British propaganda. A wooden bomber? Faster than their Messerschmitt 109? Impossible. And then the Mossy went to work. Its very first operational mission in September of 1941 was a high-altitude photo-reconnaissance flight over France. A flight of Messerschmitt 109s spotted it and moved in for the kill. The Mosquito pilot, as the story goes, simply pushed the throttles forward and left them standing, disappearing into the high-altitude haze. The German pilots returned to their base humiliated and completely confused. What was that? That was just the beginning. The Mosquito was adapted for every role imaginable. It was a day fighter, a night fighter, a coastal patrol plane, and, most famously, a nuisance raider. But the real psychological shock, the moment the ridicule truly ended, came on January 30th, 1943. This date is critical. It was the 10th anniversary of the Nazi Party taking power. It was a major holiday in the Third Reich. Hermann Göring, the head of the Luftwaffe and Hitler's designated successor, was scheduled to give a major morale-boosting speech in Berlin at 11 a.m. to be broadcast to the entire nation. Just as Göring, in his lavish uniform, stepped up to the microphone, the sound of explosions echoed across the city. A small flight of just 3 RAF Mosquitoes, flying from England at treetop level, had navigated hundreds of miles across enemy territory. They had flown so low they completely avoided all German radar and fighter patrols. They popped up over Berlin, dropped their bombs directly on the main broadcast station, and turned for home. The broadcast went dead. The spiel was canceled. Göring was infuriated. The city's air raid sirens, embarrassingly, only went off after the planes had already left.
But the humiliation was not over. A few hours later, that same day, Propaganda Minister Joseph Goebbels was scheduled to give his speech at a different location. As he stepped up to the microphone, a second wave of mosquitoes hit his broadcast station. It was one of the most precise, surgically planned, and psychologically devastating raids of the entire war. It made the Nazi leadership look foolish and, more importantly, defenseless in their own capital. The Germans were powerless. Their fighters couldn't intercept the mosquitoes at low level. By the time they were scrambled, the Mossis were already halfway home. The German flak cannons, designed for high-altitude bombers, couldn't track them. They were simply too fast. But the most insidious part for the Germans, the part that drove their engineers crazy, was the radar. Their Freya early warning radar systems were designed to get a strong echo from a large metal aircraft. The wooden Mosquito, with its only large metal components being the two engines, presented a fraction of the radar signature. It was, in effect, the world's first true stealth aircraft. Not by deliberate design, but as a byproduct of its material. Hermann Göring, the man whose Air Force was supposed to protect the Reich, was driven into a cold, blind fury. He is famously quoted as shouting at his subordinates in the aircraft industry. "It makes me furious. I get bits of paper from the aircraft industry, and they're always telling me what they can't do. And then de Havilland, a company that builds pianos and furniture, comes and builds the most beautiful aircraft. A wooden aircraft. They have the geniuses and we have the nincompoops. I could kill myself. The ridicule was over. The laughter had died in their throats. The Germans, the supposed masters of metal engineering, were being beaten and humiliated by a plane made of plywood and balsa. They tried everything to stop it. They created special high-speed mosquito hunter units called Jagdgruppen, using their best pilots in specially lightened and high-performance Focke-Wulf 190s. But even these hunters were only barely fast enough, and the Mosquito could almost always outclimb or outrun them. They tried to build their own. In a classic case of if you can't beat 'em, join 'em, they commissioned the FW-154 and nicknamed it the German Mosquito. It was a wooden, twin-engine night fighter meant to hunt the original. It was a complete and total disaster. The German glue technology, ironically, was inferior to what the British had perfected. The resin they used was corrosive, and it was found to be eating the wood. The prototypes delaminated in midair and crashed, killing their best test pilots. They simply could not replicate what the British had mastered. The Mosquito, the wooden wonder, had proven, beyond all doubt, that the problem wasn't the wood. The problem was the philosophy and the craftsmanship. This brings us in a full circle back to America, because while all this was happening, the U.S. Army Air Forces were watching, and they had some serious problems of their own. They were in desperate need of a high-performance, long-range photo-reconnaissance plane. Their daylight bombing campaign against Germany depended on accurate, up-to-the-minute photos of targets and bomb damage. They were trying to modify their own P-38 Lightning for this role. The P-38 was a fantastic, rugged plane, but it was heavy. It was loaded with cameras, and even stripped of its guns, it wasn't fast enough to always outrun the latest German interceptors. Losses on these solo recon missions were tragically high. The USAF also had a desperate need for a high-performance night fighter. The Luftwaffe was running nuisance raids over England, and American troops needed air cover at night. The Army's own purpose-built night fighter, the massive P-61 Black Widow, was a complex, radical design that was running into serious production delays. It wouldn't be ready for combat in Europe until 1944. And here, sitting right across the Atlantic, was a proven, off-the-shelf wooden design that could do both of those jobs. And it could do them better than anything the Americans had. But there was a huge problem. It was a problem that still plagues governments and corporations today. It was called "not invented here" syndrome.
The brass at Wright Field in Ohio, the center of U.S. aircraft development and testing, was deeply, profoundly skeptical. A wooden plane? From the British? It went against everything they believed in. They were the pioneers of all-metal construction. They were convinced their own P-38s and the upcoming P-61 were technologically superior. They saw wood as a step backward. They, like the Germans, had their own biases. But luckily, the man at the very top, General Hap Arnold, the commanding general of the Army Air Forces, was a pragmatist. He wasn't an engineer. He was a leader. He cared about one thing: results. He saw the RAF's performance figures. He saw the mission reports. He saw the Mosquito's astonishingly low loss rates. And he overruled his skeptical subordinates. He sent a request to the British. We need Mosquitoes for the U.S. 8th Air Force. The British, however, had their own crisis. They couldn't build them fast enough. Every Mossy rolling off the production lines at Hatfield and Leavesden was desperately needed by the RAF for their own bomber, fighter, and recon squadrons. They simply had none to spare. So a new plan was hatched. If Britain couldn't supply the planes, America would build its own. This is the license in our title. In 1942, the U.S. government signed a contract for de Havilland to provide the blueprints, the jigs, and the technical specifications, and for America to license build the Mosquito. But this immediately triggered a new crisis.
Where do you build it? The American aircraft giants like North American, Lockheed, and Boeing were experts in metal. Their factories were giant, noisy temples of aluminum filled with rivet guns and hydraulic presses. They didn't have the tools, the factory space, or, most importantly, the culture to build a high-performance wooden plane. So de Havilland did something brilliant. They had a Canadian subsidiary, de Havilland Canada, based in Toronto. This plant had been building trainers like the Tiger Moth. The British parent company sent one of their top production managers, a man who knew the Mossy inside and out, to retool the entire Canadian factory. And who did they hire to build these planes? They didn't just retrain metalworkers. They went to the high-end cabinet makers from Ontario. They hired the skilled woodworkers from the local furniture industry. They found boat builders from the Great Lakes. They essentially replicated the British production philosophy, but on Canadian soil. They were building for both the RAF and, critically, for the U.S. Army Air Forces. This is a key point. The American Mosquitoes that first saw combat weren't built in America. They were built in Canada, by a British-managed company using a British design, but paid for with American dollars under the Lend-Lease Act. These Canadian-built mosquitoes, designated the BMK-XX, began to flow south to U.S. Army Air Forces units. The Americans redesignated them as the F-8 for photo-reconnaissance. And they were magnificent. American pilots who were used to their heavy, rugged, and often cantankerous P-38s and B-25s got into the cockpit of the Mosquito and were simply stunned. It was light, it was responsive. It handled, they said, less like a military truck and more like a high-end sports car. And the speed, it was faster than anything they had ever flown at high altitude. The F-8 Mosquitoes were given to special photo-recon squadrons in the 8th Air Force, based in England. Their job was one of the most critical and dangerous of the entire air war. Fly deep into Germany, alone and completely unarmed, to take pictures of the targets for the next day's B-17 raids. Before the Mosquito, these missions were harrowing. A photo-recon P-38, a droop snoot, was still a target. The German Me-109s and FW-190s were waiting for them. Losses were high. The Mosquito changed the game. A typical mission, as told by the veterans who flew them, went something like this. An F-8 Mosquito, painted in a special high-altitude PRU blue camouflage, would take off from its base in England. The pilot and navigator would climb to 30,000 feet, push the throttles forward into the gate for maximum power, and cross the enemy coast. They would head for targets deep in the heart of the Reich. Berlin, the massive synthetic oil plants at Luna, the ball bearing factories at Schweinfurt, targets that were the most heavily defended in all of Europe. German radar would pick them up late, if at all, that small wooden signature. The Luftwaffe would scramble their best Mosquito hunter units, but the Mossy was flying at over 400 miles per hour, sometimes faster. The German fighters, gasping for air in the thin atmosphere, struggled to catch it. By the time they climbed to altitude, the Mosquito was already overhead, its cameras clicking away, and the navigator was plotting a course home. It was, for the Germans, a complete and total and now a very personal humiliation. The very same Luftwaffe pilots who had just a year before laughed at the wooden coffins from America were now watching helplessly as another wooden plane flew circles around their homeland, completely untouchable.
The American pilots adored it. They had a confidence they never had in the P-38. They knew they were flying the best photo-recon plane in the world, and the numbers prove it. The Mosquito photo-recon units had the lowest loss rate of any aircraft type in the entire 8th Air Force. They could go anywhere, photograph anything, and almost always, they came home. They also flew as night fighters.
The U.S. was still struggling to get its own P-61 Black Widow into service in Europe, so they adopted the Mosquito NF-2 night fighter. These black-painted Mossies, equipped with early primitive airborne radar, were flown by American crews to hunt German night intruders over England and later to fly intruder missions over France, attacking German airfields and protecting the D-Day invasion beaches from any Luftwaffe aircraft brave enough to fly. So, the Americans were now flying the world's best wooden airplane and proving its worth every single night and day. The ridicule from the Germans had long since evaporated, replaced by a deep and abiding respect and a burning frustration. But the story doesn't quite end there. The demand for mosquitoes from all the Allies, the British, the Americans, the Canadians, the Australians, was still insatiable. The Canadian factory working at full tilt couldn't keep up. The U.S. Army Air Forces, now planning for the eventual bloody invasion of Japan, knew they would need thousands of these long-range, fast photo-recon planes for the vast distances of the Pacific. Finally, in 1944, the U.S. government decided to build its own. This time, however, they had learned their lesson. They were no longer the arrogant, inexperienced amateurs of 1941. They didn't just hand the blueprints to a car company. The license was given, but the production was set up with extreme, meticulous care. They understood, after seeing the disaster of the PT-19s and the unmitigated triumph of the British Mossie, that how you built the wooden plane mattered more than anything else. They chose factories that had a history of high-quality, complex work. Most importantly, they brought in de Havilland engineers from Canada and England to supervise the entire production line. They enforced ruthless, British-style quality control on the glues, on the sourcing of the wood, on the temperature and humidity of the workshops, and on the curing processes. They were no longer the amateurs. They were the industrial masters of 1944, and this time they were building to the de Havilland standard. These fully American-built mosquitoes, designated the B-MK-25, were rolling off the lines in 1945. They were identical to their British and Canadian cousins, built with the same care and the same brilliant design. The war ended before these specific American-built models saw significant combat, but the circle was now complete. America had gone from building wooden planes that were a national embarrassment and a laughingstock to the enemy, to license building the most feared and respected wooden plane in the world. This journey holds a powerful lesson, one that's just as relevant today as it was in 1945. It's a lesson that many of us who have seen industry change over the decades can appreciate. It's not about flashy new technology. It's about using the right technology and using it well. If you enjoy this kind of deep dive history, the kind that goes beyond the headlines, we hope you'll consider following our channel. We post new documentaries just like this one every week, and our team works hard to uncover the details that other histories often miss. Your support helps us keep these stories alive. So, let's circle back to that original, central question. Why the ridicule? The Germans ridiculed the American wooden planes because those planes, in their flawed execution, confirmed every prejudice the Germans held. The PT-19s and the Spruce Goose were flawed in their own ways. They were the product of a nation relearning a lost art under the incredible pressure of war. They were examples of wood being used as a cheap substitute for metal. The Germans saw the rotting spars, the delaminating wings, and the grounded Spruce Goose, and they laughed. And in that narrow context, they were right. They did not, however, laugh at the mosquito. They feared it. They hated it. Because the mosquito was not a cheap substitute, it was the product of mastery. It used wood not because it was cheap, but because for that specific mission, it was better. The wooden sandwich construction of the mosquito was lighter, stronger, and critically, more aerodynamic than any metal airframe of the same size and power could have been at that time. It was a deliberate, brilliant design executed by people who were masters of their craft. The mosquito proved that the material itself is never the problem.
Wood was not obsolete. A hammer is not obsolete just because a nail gun was invented. The problem is always the design and the execution. The Germans, with their rigid focus on brute force, jet engines, and revolutionary wonder weapons, had a massive blind spot. They were so convinced of their own technological path that they couldn't see the genius of what de Havilland was doing. They saw wood, and their minds immediately thought obsolete, inferior. De Havilland saw wood and thought lightweight, stealth, speed, and performance. The legacy of these two very different wooden aircraft is stark. The flawed American trainers like the PT-19 were declared obsolete and retired almost immediately after the war. They were sold for scrap or to civilian pilots for pennies on the dollar. They were a failed experiment, a footnote of failure. The Hughes H-4 Hercules, the Spruce Goose, flew exactly one time. On November 2, 1947, long after the war it was built to fight, Howard Hughes himself taxied it out into Long Beach Harbor. In front of a crowd of reporters, he lifted the giant aircraft to 70 feet off the water and flew it for 1 mile. It was a publicity stunt, designed to prove to Congress that it could fly and to justify the massive government expenditure. After that one short flight, it was rolled back into its hangar, and it never flew again. It was, in the end, a magnificent, beautiful failure. And the de Havilland Mosquito? It flew on. It served with distinction in the Royal Air Force and in the air forces of nations all around the world well into the 1950s. It flew as a fighter, a bomber, and a photo-recon plane, remaining a first-rate, frontline aircraft even in the dawn of the jet age. Today, the American wooden trainers are forgotten by all but the most dedicated historians. The Spruce Goose is a museum piece, a symbol of obsession. The Mosquito, however, is remembered as a legend. It is arguably the single greatest combat aircraft of the entire Second World War. And the final beautiful irony? The Germans who laughed at America's matchstick planes ended up being haunted and hunted by a wooden ghost. A ghost that, by the end of the war, was being flown against them by British, Canadian, and American pilots, a true symbol of Allied cooperation and, ultimately, victory. It proves a timeless lesson, one that's just as relevant today as it was in 1945. It's never wise to ridicule your enemy's weapon, especially when you don't truly understand why they are using it. You may just be laughing at the very thing that will lead to your defeat. This story of the Mosquito is just one of many secret weapons of the war. An equally fascinating story, and one that is just as vital to the American war effort, involves the B-29 Superfortress. This was the plane that would end the war with Japan. But the B-29 had a terrible secret problem of its own. Its brand new, incredibly powerful engines had a fatal flaw. They kept catching fire. The story of how American engineers and mechanics solved this problem just in the nick of time is one you won't want to miss. Thank you for joining us on this journey into the past. We appreciate your time, and we'll see you in the next one.